Hey everyone, so we are continuing to graph in Vertex form. Today, however, I'm not going to be giving it to you in Vertex form. You're going to have to figure out how to rewrite it, that kind of thing. All right, so start by sketching this. Do whatever you think is appropriate to graph this. So because it's fractions, what I'm going to do is I'm going to start with my negative b over 2a. See what I get. So negative 3 over 4 all over 2 times 1/4. So that's negative 3 over 4 over a half. So that's times a half. So my vertex is negative 3 over 2. I'm going to plug that into my calculator and see what I get. So I got 1/4 negative 3 over 2 squared plus 3 over 4 times negative 3 over 2. 3 over 2 minus 10. I got negative 10.5625. All right, is this factorable? Now, if I try to pull out a quarter, let's see what happens. I get x squared plus 3x minus 40. Ooh, that's actually factorable. So I divided everything by 1/4. So this is actually factorable. So 1/4, and then you get x plus 8, x minus 5 equals 0. So my roots are negative 8 and 5. You could also have made a table. All right, so I need to go negative 8, 5, negative 10. Let's see, that's 4, 2, 6. My y-intercept is negative 10. So let's see, negative 3.5, so that's negative 1.5. So we're like here, something like that. I got 5, I got negative 8. So this one, see how it's kind of like fatter? That's because of the 1/4. You could have made a table. Again, I'm not telling you specifically how to do it. I kind of just took a guess. I hadn't done this in a long time, this problem, so I didn't know to divide by 1/4. I just figured it couldn't hurt anything, see what I get, and it ended up working out for me. Okay, pause the video, try this one on your own. All right, so our vertex, change the sign of the inside, outside stays the same. Negative 5, 9. I'm going to use my shifting rule of over and up. 1 squared is 1, 2 squared is 4, 3 squared is 9. But because of the negative in front, instead of up, I'm going to go down. So I'm counting from my vertex, over 1, down 1, over 1, down 1. Back to my vertex, over 2, down 4, over 2, down 4. Back to my vertex, over 3, down 9. And you could fit 16 on here if you wanted. 9, 10, 11, 12, 13, 14, 15, 16. So if you want to get that intense with it. Okay, so my roots, I can read right off the picture, are negative 2 and negative 8. My y-intercept, I have to plug in 0. So if I plug in 0, I get negative 5 squared plus 9. So that's negative 25 plus 9 is negative 16. We don't need the symmetric point, but if you want to write it, it's negative 10, negative 16. We double our vertex, and then the y-intercept's the same. And then our axis of symmetry is x equals negative 5. So that's a really straightforward, like that. This should be easy. Okay, now try this one. A little more complicated, specifically for the vertex, for the roots. So our vertex, change the sign of the inside. Outside stays the same. -2, -10. If I use my over-up rule, 1, 1, 2, 4, 3, 9. But there's a 4 in front. So what does that mean? We have to multiply our up times 4. So this becomes a 4. This becomes a 16. This becomes a 36. So we're probably not going to be able to fit much on here. So from my vertex, I'm going to count over 1, up 4. Over 1, 1, 2, 3, 4. Over 1, 1, 2, 3, 4. And then over 2, up 16, which I can fit on here. Over 2, up 16 is right there. So there's my parabola. It's kind of hard to draw on my iPad. That's it. Okay, so the y-intercept is nice. I can see it right off here. 0, 6. The symmetric point would be is -4, 6. Axis of symmetry, x equals a -2. Now here's the problem. What are the roots? The roots are right here, but what are the exact roots? How do we find them? So to do that, we have to set our equation equal to 0 and solve. So this is why I put this on your last quiz, because I wanted to make sure you could do this. This is an important skill. So I'm going to add 10 to both sides. Divide by 4. 10 over 4. Take the square root of both sides. So x plus 2 equals plus or minus the square root. I'm going to change that to 5 over, you know what? It's root 10 over 2. It's going to make it 5 over 2, but it's better if it's root 10 all over 2. And then subtract the 2. So we get -2 plus or minus root 10 over 2. And you can put that in your calculator to get the decimals, but I don't really need them. Unless we're solving a word problem, it doesn't really matter. Okay, so same idea, but this time I'm not giving it to you in vertex form. So I want you to just graph it. What would you do? What's the easiest way to do this? So you have a choice. You can either find your vertex using -b over 2a, or you can complete the square. I personally think completing the square is easier, just because I don't like plugging in, because I can do this pretty quickly. Depends on how good you are at completing the square. Right? Half of 6 is 3, and then -9, 3 squared minus 1, so I get x plus 3 squared minus 10. I think that's easier. You could have also done -b over 2a. So that's -3. And if you plug -3 into the original problem, you get 9 minus 18 minus 1, which is -10. So either way works. But now that I know that that's my vertex, -3, -10, I can just do my shifting rule. Over 1 up 1, over 2 up 4, over 3 up 9, over 4 up 16, 9, 10, 11, 12, 13, 14, 15, 16. Here's my parabola. So whichever way you find easier. Again, I like to complete the square if it looks like that. If it doesn't look like that, I probably wouldn't. But it looks easy enough. The middle term is even. Okay, so then my y-intercept is -1. I did something wrong. Oh no. Look at that. I went over too many. -1. Looks like that. It was too wide. Sometimes you just count wrong, right? I think the others are fine. So 0, -1. -6, -1, x equals -3. And again, I don't know my vertices, my roots, so I'm going to solve. So you could either solve this or you could do quadratic formula. So if you just did negative b over 2a and plugged in, you can do quadratic formula, or you could do x plus 3 squared minus 10 equals 0. I'm going to do that because I think that's easier. So x plus 3 squared equals 10, square root of both sides, plus or minus root 10, subtract 3. If you do the quadratic formula, you should get the same answer. And that's it. All right, same idea. Try this one on your own. All right, there's a negative in front, so I don't want to complete the square. I'm going to do this one using negative b over 2a. All right, so I got negative b over 2a is 4. I'm going to plug 4 in, and I get negative 16 plus 32 minus 3. That's 16 minus 3, 13. Oh, it doesn't fit on the graph. That's disappointing. Alright, so now I have to make a decision. Do I want to scale it? Or do I want to just extend the graph? Alright, I'm going to cheat. I'm going to cheat and I'm going to extend the graph. I'm going to make this go up a little more. So that's 11, 12, and 13. Because I don't want to do it. 4, 13. Alright, so now we're going down because it's negative, right? So over 1, down 1. So that's 3, 12, 5, 12. And then over 2, down 4. So over 2, we're at 2. Down 4 puts me at 9. And then 16 puts me at negative 3. Did I do something wrong? 0, negative 3. 8, negative 3. Oh, that's the 16. 9. 13 minus 9 is 4. There it is. 4 and 4. Alright, there's my parabola. Alright, so y-intercept is 0, negative 3. 8, negative 3. X equals 4. Okay, so now to solve it, I'm going to do quadratic formula. So negative b plus or minus the square root b squared minus 4ac all over 2a. So let's see, we got 64 minus 4 times 3 is root 52. So negative 8 plus or minus root 52 all over negative 2. 52 is 4 times 13. So that's negative 8 plus or minus 2 root 13 over negative 2. So then I can divide, and I get 4 plus or minus root 13. So then if you want to plug it in the calculator, if you want, you get 7.605, which is this point, 7.605, and 4 minus root 13 is 0.3944, so this point is 0.3944. All right, pause the video, try it on your own. All right, this is a pretty easy one. This one's only hard because the vertex. There's no b term, so that's 0, 8. So 0, 8. We're going down by 2, right? So instead of over and up, 1, 1, 2, 4, 3, 9. These are multiplying by 2, so 2, 8, 18, and we're changing it to down. Some kids like to put it negative 2, negative 8, negative 18. You can do that. I just think of it as going down. Over 1, down 2. over 2 down 8. So I have nice roots here. And then 16. That's a really awkward looking vertex. There we go. Okay, so my roots are nice. I got 2 and -2. My y-intercept is 8, same as the vertex. So I don't have a symmetric point, right? It doesn't make sense. X equals 0. All right, I think this is the last one. All right, so pause the video and try it. Again, I don't want to complete the square. There's a -3 in here. That's just terrible. So let's try -b over 2a. So I get -9 over 2 times -3. That's 9 over 6, which is 3 over 2. Plug that in. -3 times 9 over 4 plus 9 times 3 over 2 plus 4. 10.75. So now here's the thing. I can't really use my shifting rule here. It's not going to be very accurate. So let's find the roots. So I'm going to start by, I'm going to plot that. So 1.5, 10.75. So we're like here. My y-intercept is 0, -4. My symmetric point, double 3 over 2, and you get 3, -4. I think my roots are going to be gross too, because I don't think that's factorable. All right, well, let's find them. I'm going to use the quadratic formula. -b, so -9, plus or minus the square root of b squared minus 4ac all over 2a. -9 plus or minus all over -6. Let's see what we get. 81 minus 4 times 3 times 4. We get 33. Which is not, you can't simplify that. Okay, I'm gonna find the decimals for this one because I don't really have anything else. Like, those are my only 3 points right now. So I'm gonna plug this in my calculator. And I get 0.543 and -9 minus root 33 divided by -6, and I get 2.457. All right, so I'm going to plot those. So around 0.5 and around 2.5. And I'm just going to graph that because I don't really have a lot of, there's not a lot of nice stuff happening in this graph. So that's it. That's all I got. Sometimes that happens, you know, a lot, especially like the higher you get, the weirder, like real life problems are always disgusting. So, okay, so I want you to go onto IXL. Now go into Algebra 1 because graphing parabolas is actually mostly in the Algebra 1. Depends on the school. Most schools actually teach it in Algebra 2 now, but some still do it in Algebra 1. So go through, those are 3 problems for you to practice with. Please get an 85 or 15 minutes. Watch your time that's on the computer. All right, and that's it. And then after you do that, you have a homework assignment. Have a fabulous day.